What if Earth is actually just a giant experimental lab? Maybe an alien civilization has already made us their test subjects and has been watching our every move. The problem is, we've never received any kind of reply from them. Is that just a coincidence? Or is there another reason? Could it be that they've chosen silence because we haven't reached a certain milestone yet? Honestly, when it comes to alien life, there are just so many questions, but to truly uncover the truth, we might have to rethink the very rules of the universe. So, over the next 50 minutes, I'm going to take you on a deep dive into it all, to reveal the hidden truths that could change how we see the cosmos. Whenever we talk about the existence of aliens, most people think of a classic moment. It was back in 1950, when physicist Enrico Fermi was having lunch with his colleagues, and suddenly asked a thought-provoking question. If alien civilizations really exist, then where is everybody? That question would later spark one of the most puzzling ideas in astronomy, the Fermi Paradox. Even though the odds of alien life are extremely high, we still haven't found any concrete evidence. One possible explanation is the zoo hypothesis. It suggests that alien societies are out there, and they know exactly who and where we are, but they've chosen to hide themselves on purpose. It's like we're animals on display, and they're the invisible observers of the universe, watching our every move, silently. But their motives could be far darker than we think. If you're a Star Trek fan, you might remember the Prime Directive. Starfleet officers must not interfere with civilizations that aren't advanced enough, even if it means risking their own lives. Risky, yes, though it's fiction. This rule perfectly captures the essence of the zoo hypothesis. Somewhere on the far side of the cosmos, alien beings might have turned our planet into a one-way view cosmic zoo. They can see us brushing our teeth in the morning or walking the dog in the park, but we can't see them at all. In this theory, alien life deliberately keeps its distance under a strict non-interference policy, staying apart from our world. It's as if highly intelligent civilizations have all agreed that we should be free to shape our own future, growing at our own pace, without outside interference. And maybe, just maybe, these super advanced civilizations are 500 million years ahead of us, which would explain why we've never spotted a trace of them. Maybe that's actually a good thing, because humanity could easily be wiped out by such cosmic powers. Or worse, like the aliens in Independence Day *, they could enslave us. Sure, things like visiting an art museum might be fun for us, but for aliens, it might not be all that exciting. After all, the way they see us probably isn't filled with the same wonder and curiosity that we feel. Advanced civilizations might prefer quietly observing how we develop new technologies, like cutting-edge satellites. According to the zoo hypothesis, aliens would only reach out once we hit a certain level of advancement. So maybe boosting our technology and wisdom is the only way to prove to them that we're ready, that we've truly grown up. We no longer need their parenting style. But there are a few reasons why it's hard to fully believe in the zoo hypothesis. Maybe alien civilizations avoid contact with us because we're not advanced enough yet, but that alone doesn't explain why they'd completely ignore all our attempts to communicate. Even if zookeepers try not to interfere with the animals, I'd bet they wouldn't just turn away from a bear that suddenly spoke fluently and asked to talk. They wouldn't ignore it. That's why humans have kept trying to reach out via radio signals to make contact with beings on other worlds, but we've never gotten a reply. In 2017, about 8 miles southeast of Trondheim, Norway, a radar antenna beamed a carefully composed piece of electronic music to potential interstellar listeners. Its target was GJ-73, also known as Lytton Star. This star is about 12 light-years from our solar system, and it's a small red dwarf. Since radio waves travel at the speed of light, we'd have to wait over 20 years for any reply. But there's a big problem with radio waves. We don't even know where to aim them. Civilizations might be 17,000 light-years away, and we have no idea what frequencies aliens might use to communicate. Here on Earth, we send signals into space via radio waves. We assume that if it works for us, it should be a universal method for others. But in reality, for alien life, this might be outdated tech. That's why some research projects have started looking for other technosignatures like city lights, solar panels, megastructures, or artificial satellites. Another possible clue is studying the atmospheres of planets around nearby stars. Advanced civilizations might alter their atmospheres in ways we could detect. Even after decades of searching, we still have no solid proof that advanced alien civilizations exist, but that doesn't mean they don't. Even if we expand our search, the odds of finding one are still tiny. About 1 in 300,000. Maybe life out there is actually responding to our signals, just in ways we can't understand. The universe has existed for over 13 billion years. Humans have only been around for 200,000 of those. That's just 0.01% of the universe's age. It's like we're still learning to talk. Other super intelligent beings might be communicating in ways we can't even comprehend, yet we're still waiting for a giant UFO to land and green aliens to step out. We might be ignoring another possibility, that our interstellar neighbors are more interested in using nanotech to keep tabs on us. Or maybe they're trying to communicate with neutrinos, tiny particles with almost no mass that can pass straight through our planet without our current technology noticing. And here's another problem with the zoo hypothesis. It's hard to believe so many civilizations in the universe would all decide not to contact humans. For that to happen, there would have to be a highly organized presence in the universe, some higher intelligence, acting as the cosmic leader, giving orders to other civilizations, and making rules to keep us isolated from them. But after all, we're talking about potentially trillions of life forms. More civilizations also means more chances to break that no-contact rule. So, there's a good chance at least one planet out there is like ours, desperately searching for life in the universe. Some scientists believe that if advanced civilizations had already colonized Earth and other planets, we'd have noticed a huge gap between us by now. The zoo hypothesis actually has an even creepier twist. In the laboratory hypothesis, no one contacts us because humanity is basically part of an experiment. Earth, in essence, is just one giant science lab. Beings from other worlds could be watching us right now, studying how we react when we face disasters like tsunamis, massive quakes, and survival crises. In that scenario, a no-contact agreement among alien civilizations would actually make a lot more sense, at least for them, since it would be for the sake of scientific research. At least, from their point of view. That's how they'd see it. Another idea is the planetarium hypothesis from 2001. It suggests we're actually living in an artificial universe, some kind of virtual reality designed to trick us into thinking space is empty, when it's really not. But right now, there's no possible tool that can actually prove this idea. Besides the zoo, lab, and planetarium theories, there's another one that might explain the Fermi Paradox. Some believe no one has contacted us because humanity is truly alone in the universe. This is the rare Earth hypothesis. It argues that Earth is in an incredibly unique spot, and other planets just don't have the right conditions to support anything more complex than bacteria. You could say we're extremely lucky. Even the slightest tweak to Earth's orbit, its distance from the Sun, or its rotation speed, could make the planet far too hostile for humans or any life to survive. But then again, pondering whether we're truly alone, especially in such a vast universe, is a pretty tough question, which brings us back to the big mystery: where is everybody? Are we really just drifting alone through the cosmos? That question has haunted us for centuries. So scientists have come up with all kinds of theories to explain why we haven't made contact with other life. One of the strangest is called the dark forest theory. It's meant to explain why we've never spoken to alien civilizations. Let's start small to understand it better. Like, say, within our own Milky Way. It'll make the theory easier to grasp. Our cosmic forest is a wonderland of stars. About 200 billion of them sparkling across the galaxy, possibly with around 100 billion planets. Now, suppose just a small fraction of those worlds have life, and somewhere farther away, some of that life has evolved into intelligent beings? If that's the case, you'd think we would have met at least a few strange neighbors by now. Some maybe even searching for us. Or less waiting to be found. Now, let's sprinkle in some actual science. There's something called the Drake equation. It's basically a universal math tool for estimating how many intelligent civilizations might be out there in our galaxy. Think of it like a super smart cosmic roadmap. Tweak a few key numbers, and the equation might tell you there could be at least 20 civilizations right in our galactic neighborhood. So here's the question: if they're so close, why haven't we seen even one? The equation's not simple. It takes into account tons of factors, like how many planets in the system can actually support life, how fast stars form, and how often life evolves into intelligence. Unfortunately, how many forms of life will eventually evolve into intelligent beings? The sad truth is, astronomers still can't give precise numbers for those variables. What we have are just rough estimates. But even so, if we plug in these assumptions, we can still reach a ballpark conclusion. There should be dozens of civilizations in our galaxy. The problem is, our radio telescopes have been listening to the cosmos and hearing nothing but silence. That silence is the very heart of the Fermi Paradox. It's named after the man who, over lunch, casually asked, "Where is everybody?" Enrico Fermi. From that moment on, humanity launched into endless speculation. Some say life itself is incredibly rare. Others think the real challenge isn't life starting, but evolving from microbes into advanced civilizations. Some believe civilizations never get the chance to grow up before they destroy themselves through war, climate collapse, or runaway technology. But there's one theory that's even darker. It's called the dark forest theory. According to this idea, the universe is like a vast forest. Invisible hunters lurk everywhere. Every civilization is like a creature in that forest. It must stay quiet, because you never know if something in the dark is watching you. Why are they silent? Because they can't be sure if you're friend or foe. If there's even a chance you're a threat, the safest move is to strike first. Eliminate you to ensure their own survival. It's the cosmic version of a survival game. Under this logic, making contact with aliens might actually be the most dangerous move, because you'd be exposing yourself, like lighting a beacon and telling the hunters, "Here I am," and then every civilization learns to keep quiet, to hide. The universe sinks into an oppressive hush. No one dares make a sound. Everyone's waiting for someone else to speak first. Everyone's afraid they'll be the next to be erased. Sounds like science fiction. Exactly. The first detailed exploration of this theory was actually in Liu Cixin's novel **The Three-Body Problem**, but the idea itself was proposed even earlier by scientist David Brin. He suggested the reason we've never picked up alien radio signals might be because once you broadcast, you risk being wiped out. He even imagined the hunters might not be organic at all, but some kind of automated machine civilization running a galaxy-wide program to remove potential threats. Sounds insane. But the scary thing is, this theory doesn't require every civilization to act this way. Just one powerful enough hunter civilization would make all the others stay silent out of fear. That could explain why after over 100 years of listening, we've never detected any advanced signals. It's not that no one's speaking, it's that no one dares. But the theory has its flaws. It rests on the assumption that alien civilizations think like us, with the same risk aversion and value judgments, or that there really is one rogue civilization actively hunting down any neighbor it considers dangerous. That's no small assumption. And if you think that's already creepy enough, then the next part might actually send chills down your spine. For about a century now, we've been shouting our existence into the cosmos. And if this theory is correct, then any civilization within 100 light years might already have picked up our signals and knows exactly where we are. If there's a reason we've been hiding, like Stephen Hawking once suggested, then we might already be in trouble. But what if that theory's wrong? What if strange galactic beings are already trying to contact us? The truth is, most of us wouldn't have a clue what to do. So, let's not get cocky. In fact, some scientists have been tackling this for decades. Since the 1980s, experts have been working on a kind of manual, a guide for what to do if we ever meet our cosmic neighbors. How should we respond? Some researchers believe it's not just about worrying how alien life might disrupt our world. If they send us a radio signal, we'd also need to know how to reply. So, what do we say? Hey, we're humans. Nice to meet you. Absolutely not. We'll have to come up with something way better than that. So far, the only plan we've had comes from a rough draft in 1989. It was more of a sketch on what the world should do if alien contact ever happens, with only vague suggestions. Mostly, it just said, we should tell the public about it. Then, if the message is confirmed real, certain agencies should notify the UN. But does the UN even have a plan? Who knows? Lately, we've been exploring space more than ever. Some say we've found water on Mars. Others are convinced we've located planets that might be like Earth. So, the idea of finding life somewhere else isn't so far-fetched. But even after a century of effort, trying to talk to the cosmos, it's still been a one-way conversation. This new plan isn't just about chatting with aliens. It's like our universal voicemail system, checking messages from the stars. It's not just about decoding alien languages, it's about figuring out what those messages really mean for us. The plan also calls for writing reports, analyzing the impact of different policies, and creating clear guidelines on how to respond. So, will we ever actually hear from our cosmic friends? Only time will tell. But one thing's for sure, we can't be caught unprepared. We can't wait until the message arrives and then watch the world panic. We need a plan, and we need to be ready to face a real alien civilization. I mean, sure, we've had plenty of supposed sightings, but none have been the real deal. US authorities have investigated over 100 cases of aerial anomalies. Long story short, no little green men found. They looked more like drones, or floating tech of some kind. So, standing here at a moment that could change everything, we have to be ready. Whether our interstellar neighbors send a message tomorrow, or centuries from now, either way, we need a plan. Because it could change everything we know about the universe and our place in it. According to the Panspermia theory, life might have arrived here via meteorites, comets, or asteroids from other parts of space. While this idea is still purely hypothetical, we can still ask, could it actually be true? Traditionally, astrobiologists searching for life beyond Earth have been focused on Mars and the icy moons of Saturn and Jupiter, exploring the possibility of oceans beneath the ice. But actually, simple life forms might actually be far more common. They could be drifting right now through the space between planets, existing as dormant bacteria or spores. Some scientists point out that the extreme conditions of space could seriously damage the DNA and RNA of these spores and microbes. But others believe that enough microbes might be floating in clouds of cosmic dust, and that some could survive in a primitive form. There are actually several versions of the Panspermia theory. For example, Panspermia suggests that microscopic life might be blasted off a planet during a collision with a comet or asteroid, turning into fragments that eventually land on Earth. Panspermia, on the other hand, proposes that life could hitch a ride on starlight or radiation and travel through space. But the big question is, how could ultraviolet and X-ray radiation, combined with the vacuum of space, not completely destroy microbial life? There's also a version called pseudo-panspermia. This theory suggests that the building blocks of life could form in interstellar dust clouds and then be delivered to a planet's surface, where life would start to develop. It's a fascinating idea. But is there any evidence to actually support panspermia? In fact, there have already been some orbital experiments From 2008 to 2016, samples were exposed and collected using special equipment designed for astrobiology research. This gear was mounted outside the International Space Station, fully exposed to space conditions. The samples were later brought back to Earth for analysis. The results showed that some of them actually survived those extreme conditions. In one experiment, 100% of bacterial spores survived under simulated Martian conditions. Even more surprisingly, some seeds that survived in space grew into plants once back on Earth. Long-term exposure experiments by US satellites and Russia's photon capsule also showed that spores and even tiny animals like tardigrades can survive in space for years. In 1969, during the Apollo 12 mission, astronauts brought back a piece of the Surveyor 3 lunar lander. Shockingly, it had a strain of Earth bacteria on it. This microbe had survived, without protection, on the airless lunar surface for over 2 years. Of course, it's also possible it was brought back due to lab contamination. Meanwhile, the Indian Space Research Organization also searched for microbes in space, collecting samples from the stratosphere using balloons. The results showed that samples taken from over 25 miles up contained possible interplanetary microbial life. Air from the lower atmosphere usually can't reach such high altitudes, so this finding seemed to further support the Panspermia theory. But in 2010, NASA studied the atmosphere before and after hurricanes and found that, under certain conditions, Earth bacteria can indeed be carried to very high layers of the atmosphere. However, the main argument against panspermia is that, if it were true, then any life we found in the solar system should share a common origin and have major biochemical similarities, like the same genetic code. But that doesn't sound very convincing to many. In fact, many experts think that only when astronauts actually land on planets like Mars, Europa, or Enceladus will we truly be able to answer the question of whether life exists in our solar system. That way, astronauts could directly compare any life they find with life on Earth. Let's make a comparison. This could be the ultimate test for the panspermia theory. But until our probes find direct evidence of life in space, this theory can't be proven. Now, if we look at the multiverse theory, things get even more complicated. If this theory is true, then our universe isn't the only one out there. That idea is both thrilling and a bit unsettling. Of course, not every scientist is on board with such a mind-bending concept. Honestly, the idea of contacting a parallel universe sounds about as likely as winning the lottery while riding a unicycle. But it's worth noting that this idea is no longer confined to science fiction. Some scientific theories actually support the existence of parallel universes, and that has sparked heated debate in the scientific world. Just imagine, the universe we live in is already mind-blowingly huge. Scientists estimate it holds billions, even trillions of swirling galaxies, and each galaxy is packed with countless stars. Some researchers even suggest the diameter of the universe could be an incredible 7 billion light-years. Others think it might actually be infinite. So, could there be things out there we haven't even discovered? Some real-world scientific theories suggest the universe isn't just what we can see. It might even coexist with other universes, overlapping or beyond ours. These fascinating ideas about the multiverse and parallel worlds often intertwine with more familiar science we already know, like the Big Bang Theory, relativity, and quantum mechanics. To understand what's out there, we still have to lean on the theories we're most confident in. So, let's rewind to 13.7 billion years ago. According to the Big Bang Theory, everything we see today was once packed into a tiny point. If the Big Bang Theory is correct, then everything exploded outward in that instant. The universe expanded faster than the speed of light, and in less than a second, it grew to the size we see today. The way the universe expanded has led some clever researchers to wonder if there might be more than one universe. They ask themselves, did this sudden, violent expansion really end everywhere at the same time? We know that the expansion of our universe stopped 13.8 billion years ago. From Earth's perspective, it has reached its current size, but in some mysterious corners, the expansion might still be happening. Some theoretical physicists suggest that when expansion ends in one place, a brand new bubble universe forms. The catch is, you can't just hop from one bubble to another, like some kind of interstellar tourist. These bubble universes are expanding infinitely, their edges moving far faster than light, and racing away from us. That's where things get even more puzzling. Even if we somehow reached the edge of our local bubble and met the next universe, well, those same theoretical physicists say it could be completely different. It might have totally different laws of physics, which, for us, would make it an extremely strange place. Following that logic, some believe that within this vast, bubble-filled multiverse, there might be other life forms just like us. The trouble is, they're drifting farther away, and our paths will never cross. Meanwhile, some incredibly smart researchers are trying to connect the idea of parallel universes with quantum mechanics. Make the connection. Quantum mechanics is basically all about complex math models describing tiny examples. According to its theory, these examples can exist in multiple states at once. They're called wave functions, and they contain all kinds of wild possibilities. But here's the catch. When we actually observe them, we only ever see one outcome. It's like the universe is playing hide-and-seek with us. Now, there's a theory called the many worlds interpretation. It says that every time we observe one result, another universe pops into existence, where a different outcome becomes reality. It's like our universe is a massive tree, branching endlessly into countless versions. These parallel universes can never mix. So, you might never know if there's another you out there, living a slightly or completely different life. The many worlds theory is bold and nearly impossible to prove or disprove. For science, that's not easy, because scientists love to test ideas through experiments. But if the universe truly is infinite, why couldn't there be infinite universes too? Just imagine the universe as one giant cosmic playground. Some experts believe that if the universe is truly endless, then its building blocks can only be arranged in a limited number of ways. Eventually, patterns would have to repeat. If that's true, then somewhere out there, there could be another version of you, living the exact same life, down to eating the same lunch you had yesterday. So, do we have any proof that these parallel universes actually exist? Some people say we do. Have you heard the strange tale of the man from Tord? A man once showed up at a Japanese airport, claiming he came from a completely unknown country called Tord. Some believe it was proof of time travel. Others think it shows he came from a parallel universe. Although, you might want to believe this story is real. The problem is Tord is a place you've never heard of, because it doesn't exist at all. Not today, nor back in the 1950s. When this incident supposedly happened, the man mysteriously vanished the day after arriving in Japan. Let's rewind to that day, July 1954, when the self-proclaimed man from Tord was said to have landed in Tokyo. Descriptions say he was a bearded man who spoke French. At first glance, nothing seemed all that strange. Right, but depending on which version of the story you hear, things take a twist. In one version, when the man handed over his passport to be stamped, the Japanese officials' eyes went wide. The passport looked legitimate, but the country Tord was one no one had ever heard of. Even the officials and staff were baffled. So they decided to take our Tord visitor to a cultural office. In another version, the man flat out told inspectors he was from Tord and showed them his passport, but the inspectors clearly didn't believe him. This man from Tord tried to convince them that his homeland really did exist. According to him, Tord sat between France and Spain and had existed for about 1,000 years. To back up his claim, he even pointed on the map to the exact spot where Andorra is. Clearly, things were getting stranger. They decided to detain him, suspecting he might be up to something. So, they put him up in a nearby hotel for the night. But didn't let their guard down? They even stationed people outside his door to keep watch. What happened next will probably surprise you. The next day, when officials came to his room to continue the investigation, the man had vanished. Even stranger, there were no signs of escape at all. And here's the real twist. All of his personal documents had mysteriously disappeared too. If that man from Tord was actually a time traveler, or maybe some kind of interstellar explorer, some people have really taken this into sci-fi territory, trying to come up with explanations for this bizarre case. Believe it or not, there are plenty of people online who treat him as proof of parallel realities. One of the wildest theories is that this man accidentally wandered into a parallel dimension and somehow ended up in this Japanese airport. In that alternate universe, there's an Earth just like ours. Only they call it Tord. Another theory says he was actually a time traveler from the future. But, sorry to burst your bubble, the most logical explanation is that this whole story was probably just someone's overactive imagination. With so many versions of the same tale, people probably kept adding more and more dramatic details until it became a sensation. Eventually, it turned into a full-blown urban legend. There's almost no real reason to believe we've ever met a time traveler or interstellar adventure here on Earth. But in 1994, something strange really did happen. As the sun began to set, two figures quietly made their way to the glass dome of Biosphere 2 in Arizona and opened the emergency exit. They were determined to rescue 7 people who'd been trapped inside for a month, risking their own lives to do it. The mission was a success, but they were arrested for trespassing and damaging property. The rescuers were Abigail Alling and Mark Van Thillo. They were among the original 8 participants who'd lived inside as human guinea pigs. They didn't want anyone else to go through the nightmare they had. You see, this $150 million experiment was designed to see if humans could create livable conditions on other planets, like Mars. To make it happen, scientists built a miniature world with over 3,000 species of plants and animals. Biosphere 2 was a sealed, 3-acre ecosystem with its own mini rainforest, private beach, coral reef, grasslands, wetlands, and even a desert. From 1991 to 1993, nothing was allowed to enter or leave. The 8 people inside called themselves Biosphereans, wore matching Star Trek-style jumpsuits, grew their own food, and breathed their own recycled air. At first, spirits were high. They enjoyed 5-star hotel-style breakfasts at least for a while, but after a few months, things took a dark turn. The whole team was starving. Their skin even turned orange. Here on Biosphere 1, better known as Earth, you can order a pizza and have it in 2 minutes. But inside Biosphere 2, it took them for whole months just to make 1 margarita pizza. They had to harvest wheat to make the dough and milk goats to make the cheese. Their goal was total self-sufficiency, a completely independent ecosystem. And they really became part of the atmosphere. And when they breathed, the carbon dioxide they exhaled fed the sweet potatoes they grew, and those sweet potatoes became part of them. They were basically eating the same carbon. They ate so many sweet potatoes, their skin literally turned orange from all the excess beta-carotene. It might have looked funny at the time, but it pointed to a serious problem. Biosphere 2's crop yields were disappointing. The crew began going hungry. Hunger made them irritable and edgy. Bursts of sudden anger led to things they'd later regret, like stealing bananas. They even had to lock the fridge. In the first 6 months, each person lost between 18 and 58 pounds. Every day, one person had to act as food monitor. Fresh produce went to the cook, who logged the nutrition info into a computer to make sure they hit their daily target calories, protein, and fat. At first, meals were buffet style, but as hunger got worse, the cook began carefully portioning each plate. Their diet was mostly sweet potatoes, carrots, fruit, and the occasional Sunday meat. It was supposed to fuel them through grueling 80-hour work weeks. But even after every meal, they were still hungry. And they often dreamed of McDonald's, sushi, Snickers bars, and cheesecake. Meanwhile, the air was running out. The place was completely sealed in steel and glass. Steel on top. A solid steel floor on the bottom. Management inspected every single item coming in to avoid synthetic materials giving off toxic gases. Living spaces had wood and wool furniture. No chemical deodorizers allowed. No blowing out birthday candles. The Biosphere. Residents relied on their own crops and lots of rainwater to produce enough oxygen to stay alive. But their oxygen was disappearing fast, nearly overwhelmed by their own CO. Worst of all, they had no idea why. With 9 months left in the experiment, oxygen had dropped from 21% to about 15%. Like living on top of Mount Fuji. They felt awful, basically dragging themselves around the Biosphere, stopping mid-sentence just to catch their breath. Then came sleep apnea. Some would wake in the night gasping for air in an effort to bring CO levels down. They tried desperate measures, planting like crazy, cutting back on watering, even stopping tilling the soil. Nothing worked. So they decided things had reached a dangerous point and called for help. A refrigerated truck showed up and started pumping pure oxygen inside. As the oxygen flowed in, they couldn't help but laugh and run around the place. But the ecosystem had already collapsed. Hummingbirds and bees vanished within months. Plants were no longer thriving, and pest-like insects and broadleaf weeds attacked the crops. Cockroaches took over. They had introduced for kinds to recycle organic waste, but the common household roach became the ultimate survivor. They sneaked in and bred like crazy, becoming a major threat to the crops. At night, when the lights went out, the kitchen was swarming with roaches. To fight back, the team coated coffee mugs with grease and put papayas inside as bait. The roaches would climb in, but couldn't escape the slippery trap. Hunger, low oxygen, and pests were enough to drive anyone mad. Fights broke out, cups went flying, and some even spat at each other. In the end, the whole team split into 2 camps. They stopped talking to each other, even when passing in the hallway. They wouldn't make eye contact. One group wanted more food and oxygen, and to keep a certain dignity while doing research. The other side insisted that they could survive without outside help, no matter the cost, no matter the cost. In reality, the sealed dome had already been breached. Just 2 weeks later, a resident named Jane Pointer, while cooking, accidentally sliced off the tip of her finger. The mission doctor tried to stitch it back on, but failed. Within days, her finger turned black. She had to leave for surgery at an outside hospital. A few hours later, she snuck back in, carrying a tote bag full of supplies, including computer parts and rolls of color film, and slipped into Biosphere 2. Months later, reporters discovered this secret supply run. As a result, many began to question the experiment's credibility. The media covered it like a reality TV show, calling it trendy ecotainment. Headlines around the world made it sound like they were on the brink of death, so much so that family members grew worried and called to ask if the residents were actually okay. The crew began to feel like they were living in a human zoo, with tourists traveling from far away just to stare at them through glass walls. In the first 6 months alone, over 150,000 people came to see the place. Biosphere 2 eventually became a pop culture joke, inspiring the movie Biodome and decades of comedy sketches. You might be wondering, why didn't they just quit? Why not just walk out the door? Well, no environmentalist wanted to be the first to admit they couldn't hack it, and besides, they still held on to hope that they could crack the puzzle of building a second Earth. In the end, they actually solved the mystery of the missing 7 tons of oxygen. It had been absorbed by the concrete, and while low oxygen seemed like their biggest challenge, the residents later said that managing human relationships in a sealed habitat was even harder. From the outside, the experiment looked like a disaster, but the team learned some truly valuable lessons. They proved that a closed ecological system could run for years. They contributed to coral reef restoration research, Their farm showed high yields and a complete nutrient cycle, all without using toxic chemicals. And if you're wondering, Biosphere didn't end there. A second mission took place in March of 1994. Now you can go back to the start of the video to see how that one turned out. Of course, maybe there's another universe, like a dark mirror image of our own, where time flows backwards. That upside-down world might even be the source of dark matter, the invisible stuff scattered all across our universe. And maybe, in that other universe, there's another version of you, who woke up this morning, but chose a white t-shirt instead of a red one, and ended up on a completely different life path. A tiny choice, changing everything. But let's start with this mysterious dark matter. It makes up most of the mass in the universe, and yet, we're still not sure what it actually does, or where it comes from, because it doesn't behave like normal matter. We can't see it. We can't feel it. We only know it's there, because it seems to bend gravity itself. Even though normal matter and dark matter are completely different, they seem to exist together in some sort of balance. Some scientists believe there must be a connection between the two. A new theory suggests that for every movement in the world of normal matter, there's a mirrored counterpart in the dark matter world, almost like a bridge linking to separate realms. There's also a strange coincidence in normal matter. Leptons and protons have nearly the same mass that allows them to bond together and form stable atoms, making all the matter we can see possible. If protons were just a little heavier, that balance would fall apart, and atoms could never form. In the mirror universe of dark matter, things might be different. Maybe there, the proton equivalent can't bond with other particles, leaving behind lonely, isolated particles. That could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms forming a dark periodic table. For a long time, scientists thought there was only one kind of dark matter, even though the examples we found are similar in some ways, like being almost completely invisible. They might differ in size, speed, and how they interact with normal matter. If this theory is right, it means our universe and the mirror universe of dark matter might have interacted at some point in the past. Studying how elements formed in the early universe might give us some clues. This flipped world idea has stirred up huge curiosity in the scientific community over the past few years, and even left some people scratching their heads. Astronomers use a theory called the lambda CDM model to explain the makeup and behavior of our universe. According to this model, the universe is mostly made up of two things: dark energy and dark matter. Dark energy acts like a force, pushing the universe to expand faster, while dark matter uses gravity to pull things together, like the cosmic glue. Normal matter, like stars, planets, and comets, is just a tiny fraction of the total. This model also describes the Big Bang and how everything started from a hot, dense beginning. Since then, the universe has been expanding and changing. But while this model fits in many ways, it still can't explain everything we see. If you drew this model on paper, it would look like flat pancakes, stacked on top of each other. Each pancake represents the state of the universe at a particular moment in time. Yesterday's universe would be below today's, but slightly smaller. Eventually, you'd see the universe's history, forming a giant upside-down cone. At the very tip, you'd have the Big Bang. Beyond that point, with our current tools, we just can't look any further back. More importantly, we still don't know exactly what happened right after the Big Bang. But if we only follow the math, the universe could extend past that turning point in history. That would mean it might run backwards, creating a mirrored, upside-down version. From our point of view, time would flow in reverse. This kind of wild idea not only challenges our understanding of the universe's origin, but also sparks questions about the very foundations of physics. The excitement over a mirror universe comes partly from a scientific instrument stationed in Antarctica and its discoveries. This device detected some strange, high-energy particles that seemed to burst up from beneath the Antarctic ice. The problem is, these examples don't behave the way physics predicts, at least, not how we'd expect. Scientists think they might be a kind of cosmic ray. They travel through Earth from space, then come out the other side. But the ones we've seen shouldn't act like that. That's because higher energy examples would usually collide with something inside Earth. On the way, they wouldn't just pass straight through like these do. It's almost like they're moving forward and backward at the same time. So far, there's no solid proof of a mirror universe. These examples could just be a totally new type of particle we haven't discovered yet. Scientists need to study them more closely to figure out why they behave this way. It's kind of like dealing with a curious 4-year-old. But what if it's not just one parallel universe? What if there are many? This multiverse idea comes from theories like cosmic inflation. The inflation theory says our universe underwent a massive expansion in its earliest moments. While inflation stopped in our patch of the universe billions of years ago, it might still be going in other regions of the multiverse. Those areas could form their own universes with different physical laws and unique features. Ours is the only one we know of so far that can support life. For example, we have stable stars that provide heat and warmth, essential for living things to function. We also have abundant elements, like carbon and hydrogen, the building blocks of life. The multiverse idea offers one explanation for why our universe happens to be so perfectly suited for life. It could also explain why, in other, countless universes, life might be far less likely. One fascinating idea from multiverse theory is the concept of duplicates. In these parallel universes, there could be exact copies of us. This concept suggests that somewhere in the vast multiverse, there may be countless scenarios where our duplicates are living through similar events. Before we even think about traveling to other universes, maybe we should first understand our own. For example, there's a distant galaxy that might not have any dark matter at all. It's about 250 million light-years away. At first glance, it looks pretty normal. But when we take a closer look, we find no sign of dark matter at all. If we eventually discover more galaxies like this, it could change how we understand galaxy formation. Normally, dark matter is thought to be essential to the process, like the glue that holds everything together. Interestingly, this galaxy is dimmer than most and has fewer stars. When scientists first spotted it in 2019, they thought it might lack dark matter because it was spinning too fast. A galaxy's rotation speed tells us how much mass it has. By comparing that speed to the visible matter we see, astronomers can estimate how much dark matter it must have. But in this unique galaxy, the math says there's none. Among all these theories, there's even one that says dark matter might not be real at all. New research suggests maybe we've been looking for something that doesn't even exist. They think our understanding of gravity might not be good enough to explain why some galaxies act strangely. So maybe dark matter behaving abnormally. So they believe that dark matter isn't actually the cause of these strange effects. Maybe we just don't fully understand how ordinary matter really works. Their idea is based on something called modified Newtonian dynamics. This theory suggests that at extremely large distances or very low speeds, gravity behaves differently. A Dyson sphere is a purely theoretical mega-engineering project. Picture a giant sphere surrounding a star, packed with platforms, orbiting it in tight formation. It's imagined as the ultimate solution for energy production and living space. Whoever builds one would have an enormous surface area for habitation and could capture every last bit of solar radiation and heat. The first to propose this unusual concept was British-American physicist Freeman Dyson. According to him, an intelligent alien civilization might consider building such a sphere after colonizing the moons and planets of its local star system. As their population grows, they'd need more and more energy just to keep things running. Dyson calculated that if such a society grew at just 1% per year, their land and energy needs would skyrocket by 1 trillion times in only 3,000 years. If they had a Jupiter-sized planet in their solar system, they could dismantle it and spread its mass along a ring-like orbit, about twice the distance from Earth to the Sun. That much material would be enough to build countless orbital platforms. Each one could be 6 to 10 feet thick, letting the civilization live on the side facing the star. This shell would be perfectly habitable and could hold all the solar harvesting tech they need without the shell collapsing inward toward the star. But once all that sunlight is captured, the sphere would need to re-radiate it. Otherwise, the heat would build up and eventually melt the structure. That means a Dyson sphere wrapping a star might look dim, or even totally dark, depending on how dense the orbital platforms are. At the same time, it would shine unusually bright in infrared, invisible to the naked eye. So, the Dyson sphere is considered a technosignature, a sign of activity that astronomers could use to detect the presence of intelligent life in the universe. Some researchers on Earth already have infrared maps of the night sky. They're studying these maps, hoping to spot a Dyson sphere. So far, no one has found one. But one study has flagged a few possible Dyson sphere candidates. The researchers used a special data processing pipeline to combine and analyze huge amounts of information. One of their main search criteria was detecting excessive infrared radiation and being able to tell it apart from the kind naturally emitted by space objects. That's crucial. After sifting through millions of objects with complex filters, the team narrowed it down to 7 possible Dyson spheres. Further analysis will be needed to figure out exactly what they are. To do that, scientists plan to use optical spectroscopy, which could reveal more details about these objects and where they came from. At the same time, the researchers admit these candidates might have other explanations. For example, they could be young stars with debris disks, or circular protoplanetary disks. Only more research will tell if we can actually find one in our galaxy. Finding traces of other civilizations, so far, that's still an unanswered question. Interestingly, Dyson spheres have been a hot topic in sci-fi stories. As far back as 1937, in Olaf Stapledon's novel, Star Maker *, there's a description of a system in a certain galaxy surrounded by light traps that capture the sun's energy for intelligent beings to use. Because of that, the brightness of the whole galaxy dimmed. In another novel, *Ringworld*, the author imagined a massive ring-shaped structure around a star. This is the James Webb Space Telescope. That's the farthest it can see with its eyes. Pretty impressive, right? But let's zoom in a bit more, and even more. The image gets fuzzier and fuzzier. Wait, what's that shadow? It's a gigantic telescope that can turn those blurry images into crisp, detailed views. NASA's Roman Space Telescope is set to launch in 2027. It might help us unlock cosmic mysteries, including the nature of dark matter. Don't worry, James Webb will keep showing us the beauty of the universe and solving puzzles along the way. But now, astronomers have a new mission. They want to deploy an even bigger space telescope next. The project is already well underway. The Nancy Grace Roman Space Telescope could very well usher in a new era of astronomy. Scientists hope this telescope will gather more data than all of NASA's previous missions combined. Hubble and Webb have been amazing at zooming in and capturing clear, highly detailed images. But the Roman telescope will give us a much wider field of view. It'll be able to capture infrared images 200 times larger than Hubble's, and at the same time, keep the same razor-sharp level of detail. But even with its perfect images, its main job will be large-scale surveys. Say we wanted to study clusters of stars in a nearby galaxy. That's too big a field for Hubble. If we used Hubble, we'd have to stitch together dozens of separate shots into one big image. With Roman, though, you'd only need one click to get a sweeping panorama of the entire galaxy. Take this recent mosaic of the nearby Andromeda galaxy. It was built from 400 individual Hubble images stitched together. Roman could capture the same ultra-wide shot with just 2 images and the same level of detail. Not only is that cool, it means we'd get an unprecedented flood of data. Once we have a panoramic view of the cosmos, NASA and other space agencies might finally be able to answer some of humanity's oldest big questions. One major goal is to put Einstein's theory of relativity to the test. This theory has been well proven at the scale of our solar system, but on a larger, cosmic scale, it hasn't been fully tested. According to the theory, visible matter should slow the universe's expansion. Yet, the universe keeps expanding, and it's speeding up. So, astronomers blame this accelerating expansion on a mysterious ingredient. Dark energy? They believe dark energy makes up about 68% of the universe, and they hope the Roman telescope can give us data to precisely measure our position and distance from millions of galaxies across the cosmos, and maybe, just maybe, help us finally figure out the expansion speed of the universe in different regions. Could ultimately reveal to us whether Einstein's theory of gravity needs an update. Another major goal of the Roman Space Telescope is to detect hundreds of new exoplanets in our Milky Way. It will use a technique called gravitational microlensing. When two stars line up just right, the one in front can bend and magnify the light from the one behind it, and if that front star has planets, we can see how those planets affect the background star's light. Roman aims to study billions of stars to give us solid statistics on how many of them host exoplanets. This cutting-edge telescope won't just find new exoplanets. It's also carrying another key instrument called a coronagraph. It can directly image exoplanets near their parent stars. This is incredibly challenging because you have to block out the star's glare. After all, stars are way brighter than the planets you're trying to see. Roman's coronagraph will attempt to directly capture giant planets like Jupiter, while actively correcting and sharpening the image. If it works as planned, it could be a fantastic tech demo and pave the way for future space observatories to build on. These future telescopes could directly capture Earth-like planets in the habitable zones of their stars. But Roman isn't the only project that could change the way we explore space. Other ideas include the Poseidon concept, a revolutionary telescope design based on special optical components. These optics could overcome one of space telescope's biggest limits, their fixed aperture size. Poseidon's technology could give us massive but ultralight telescope mirrors, making it possible to launch an entire fleet of identical giant telescopes. They'd have incredible light-gathering power, helping Poseidon survey thousands of Earth-like worlds in habitable zones. Ultimately, we might find signs of life in the atmospheres of these planets. Over the last 2 billion years, Earth's atmosphere has changed dramatically. It's become rich in free molecular oxygen and ozone, highly reactive gases, mixed with water vapor and methane, creating a unique atmospheric signature. The presence of these gases could be detected from far away as signs of life. And we're talking galaxy-scale distances, not just nearby, but spotting these chemical fingerprints in the reflected or filtered light of an exoplanet's atmosphere requires enormous telescopes. NASA's Kepler mission discovered over 4,000 planets, but so far, no current or planned space telescope has a big enough mirror to actually search for life in an exoplanet's atmosphere. Finding and correctly interpreting signs of alien life is incredibly tough, but the Poseidon team hopes to build a telescope capable of studying tens of thousands of Earth-like worlds. And then there's the European Space Agency's Euclid mission. Its goal is to explore the composition and evolution of the dark universe. This mission is named after the ancient Greek mathematician Euclid, who lived around 300 BC in Alexandria and founded the field of geometry because the density of energy and matter is closely tied to the geometry of the universe. This mission is named after him. This space telescope will create a massive 3D map of the large-scale structure of the universe across space and time by observing billions of galaxies and covering over a third of the sky. Euclid will try to figure out how the universe expanded and how its structure formed throughout cosmic history. Hopefully, it can shed light on gravity, dark matter, and the nature of dark energy. As far as we know, dark energy is probably accelerating the universe's expansion. As for dark matter, it drives the growth of cosmic structures. But experts still don't fully understand exactly what dark energy and dark matter are. By studying how the universe evolved over the last 10 billion years, we might finally figure out how it has expanded and changed over time. With this data, astronomers may be able to deduce the nature of dark energy, dark matter, and gravity. It could help us understand them with greater precision. The Euclid Space Probe stands about 15 feet tall and 12 feet wide. It has two main components: the payload module and the service module. The payload module includes a telescope with a 4-foot diameter and 2 scientific instruments, a visible light camera and a near-infrared camera, or spectrometer. The service module contains satellite systems, such as power generation and distribution, data processing, electronics, thermal control, and more. One of the reasons space is so terrifying is its unpredictability. Even though 99.99% of the universe is empty, if you do encounter something out there, chances are it could easily end your life. And some things are far scarier than others. Take gamma ray bursts, for example. When a massive star explodes, it unleashes incredibly powerful gamma rays that can wipe out anything in their path, whether it's an asteroid or a planet. In our Milky Way, a gamma ray burst happens roughly once every 5 million years. Then there are vampire stars, scientifically known as O-type stars. These giant blue stars feed on smaller neighboring stars, slowly consuming them with their immense gravity. But vampire stars don't live long. Once they've devoured their smaller companion, the gravitational forces inside cause them to explode into a supernova. Black holes are both fascinating and terrifying. They swallow anything that comes too close and warp the very fabric of space-time. Can they get even scarier? Absolutely. When we talk about rogue black holes, things get even more unsettling. One discovered in 2016 is heavier than the Sun and moves at over 1,240 meters per second. This black hole was likely ejected from its home galaxy after colliding with another galaxy. Right now, it's about 2 billion light-years away. Then there's the Great Attractor, a mysterious cosmic anomaly 150 to 250 million light-years from us. Its gravitational pull is so immense, it can draw entire galaxies toward it, making them cluster together. But the scariest part, we still don't know what it is, or whether our galaxy will one day fall into its grasp. Meteors might not sound all that thrilling or scary, but they're actually one of the most realistic threats to Earth. Every year, thousands of meteors smash into Earth. Luckily, most of them are way too small to cause any serious damage. They either burn up in the atmosphere or plunge into the ocean. Our sun can be pretty terrifying too, especially when it releases bursts of intense energy. Solar flares. These flares are often accompanied by coronal mass ejections, huge bubbles of charged gas that can rocket away at mind-blowing speeds. Even the most powerful volcanic eruption is nothing compared to the energy from a solar flare. It's not even close. A solar flare can unleash energy that's 10 million times stronger than a volcano. In just minutes, a single flare can blast out billions of tons of charged particles, and the temperature off the charts, reaching millions of degrees. Astronomers believe solar flares happen when certain areas of the sun's magnetic field get twisted out of shape. Then, all at once, the built-up energy is unleashed, sending out light and particles, mostly electrons and protons. Most flares last only a few minutes, but some can go on for hours. A powerful solar storm could even trigger a devastating global blackout on Earth. Next on the cosmic danger list, dark flow. In theory, all galaxies should be drifting away from each other evenly, but there's a massive cluster of galaxies that seems to be moving at 600 meters per second toward a small patch of sky between Lyra and Draco, and no one knows why. That's why this baffling phenomenon is called dark flow. Space also poses plenty of threats to astronauts. For example, spending long periods in space can actually alter human DNA. Scientists believe that the stress of extended space travel can cause astronaut cells to rewrite their genetic code. The worst part, those DNA changes are permanent.